Good evening, everyone. I will start my talk because it's going to be a bit long, not like how it was planned. Let me introduce myself again for those of you who have just arrived. My name is Norbert. If in any point in time I'm moving in front of the screen, please wave and yell. I don't see it. So, as I mentioned before, I do the organization of this lovely Meta group for you, bunch of lovely people. But I also have to earn my bread, and on a day-to-day basis I do technical stuff, as most of you guys. I actually try to solve problems of our partners in a way that you would imagine it in 2020. So automation, lovely automation, all kinds of, starting from if-else to more fancy stuff. But this evening, I'm actually here to talk about machine learning in JavaScript, roughly. I would like to start with a disclaimer. I do not consider myself expert in any of these topics, actually in any topic at all. But I'm still here talking about shit, so this should encourage you as well to do the same.
Real life shit posting.
Exactly. Anyone is a machine learning expert in the audience? Awesome. For the sake of recording, no one. It's a safe zone for me. Anyone from abroad? No one is from abroad. Everyone lives in Hungary. Thanks you. Awesome. This will be useful for you guys, mostly. So actually we're here to answer 3 questions this evening. First and foremost, how do you actually do AI? This can be deep learning, machine learning, from nothing. So if you have a problem and no background with anything, just to make it fancy AI-ish. Can you do it with JavaScript? Because this is a JavaScript meetup. Well, I crossed out some part because I gave some leverage to myself to mostly JavaScript. You'll see why. And the most important question is, when should I visit my mother? Now, if it's not obvious to you how these 3 questions are connected, I got you covered. I heard a mom joke there somewhere. Okay, so I'm just kidding. I actually grew up in Serbia, so this is not in Hungary, that's a different country, which means I still have friends and family living there, which I try to visit regularly. Try is being emphasized here. But you will get the picture if I take you on a trip to my mother. We go all together to visit my mother. I took the liberty to help you guys out with an itinerary of our nice travel stuff. As you can see, Google Maps draws a nice line. Since I'm not an expert in geography either, I help you out as well. We're here right now in Budapest. I highlighted that part, and we're going down there to the south. And along the way, we cross a small thing called the border. Now, at this point when I was creating my slides, I was contemplating on putting like an image of the wall here from Game of Thrones or Mordor from Lord of the Rings, because that would reflect it more accurately. Like, Google is very politically correct. He mentions that you might have some issues there, some inconvenience, not necessarily might. I mean, I was thinking about this sentence. If I'm going from another country, or from one country to another country, how can I do that without crossing borders? I do trust Google's expertise over mine, so I'll take their word for it, but I'm going to give you a real picture of how that looks like. You remember the 2-hour trip. That's not necessarily true 2 hours all the time, meaning really never. And I took the liberty to pick some articles from the media to show you that this can go from a couple of hours to half a day. Really, that sucks. Yes, there are ways to figure out what you can expect on the border. Like there are crowdsourced solutions from Facebook group to a mobile application where I can write, okay, it took me 45 minutes to cross the border now. The government also has an official site that lists the expected queue times on all. I'll wait whether you guys figure it out or not. So most of the crossings from Hungary. But there's a problem with all of these solutions. They tell you what the queue time is right now. They won't tell you what it will be tomorrow or what the queue time was yesterday. This is useful if you're on the road and you see that, I wanted to cross at that crossing station and now there's like a 2-hour-long queue. I can take a 50-mile detour or kilometers or whatever, and then you arrive at a different crossing where there's no queue. But we want to plan our trip, right? For that, we need to know what the queue time will be. For that to happen, we need to predict the queue time. Hence, our savior is born. This is the name of the project I will be talking about. It's called, it's not 6R before, it's hot R. No, come back, what happened? So for the non-Hungarian speaking participants of this evening, there's also an JavaScript-ish explanation. I think I can get this working in JavaScript, I'm pretty sure of it. But basically, hot, 6, you put together the strings, bam. This was the pinnacle of my presentation, so enjoy it, breathe it. Oh, for fuck's sake. I'm not sure why it does.
This was the mostly JavaScript.
Okay, so how do we get there? Wave at me when it's gone. I'm not sure what the problem is. Actually, it's 3 simple steps. We need data. We do stuff with that data. Bam, we have AI. We're going to go through these steps one by one. So let's talk about gathering data. If you remember, I mentioned that there's a site, a government site, that tells you roughly what the queue time is at the border. I mean, it's easy to fetch data from there. Web crawling, JavaScript is awesome at that. Who has written a web crawler in their development? Quite a lot of people. Yeah, it's pretty straightforward. It's like a crappy browser. I use some data, works awesomely. How this looks like? Well, I'm not being rude. There isn't really an English translation for the official government site for showing border traffic information. So I can do Google Translate for you guys, next best thing. It's quite easy to use. You click the drop-down, pick the country you want to go to. You click the It Can Go button. Then, what? It can go. So once you click the It Can Go button, it lists a number of crossings for you, including the crossing name, the open hours, and the queue time you can expect for a specific traffic type. In this particular case, for trucks, it's a measly 3 hours. Essentially, what we want to do here is very simple. Since police.hu does not have an API, does not have an historical data, we have to do that for ourselves. So we just create a way to get HTML to JSON. That's it, nothing more. Now, I talked about historical data. So we can do that, running it roughly every 10 minutes. That's very optimistic because I'm assuming that the border control will update those values every 10 minutes. Like, of course they do, but let's be positive here. And you have to have it running for a while. How long? What do you guess?
1 year. 3 years.
Good. 1 year. There's a reason for this particular number because I promised to do this talk beginning of the year. Otherwise, I will still leave it running. That's really the amount of data you can have fun with. But yes, and now we have our data. Next comes the fun part, data science. It's really about figuring shit out about your data, including cleaning it up. I will get back to the details there. JavaScript is okay-ish in this regard. I mean, there are dedicated libraries for this, like DataForge. It's pretty. Actually, I wasn't aware of DataForge before doing this project, and I was surprised how good it works. So I recommend checking that out. It's useful for other transformational tasks as well. And I picked SQL. If you ask me, SQL is the closest thing we have to magic, especially database engines. Who uses SQL with Node.js? As I expected, only a few people. Because in JavaScript, well, you have JSON, MongoDB, I don't care if my data is lost, YOLO, there's always tomorrow. That sums up JavaScript developers. No, I'm not bashing Mongo or anything, it works. It's just that I would like to raise the awareness of the features and power that SQL or a relational database engine gives you. And with the help of that, we can gain in-depth understanding of our data. So I will do the risky part now, the demo. So who has used Metabase before? Awesome, no one. Great, I'm very happy. I was also not aware of Metabase. It's the best tool ever. It's very simple. It has a lot. You download a jar. It's a Java archive. You just run that jar. Bam, you have a server. You give it a connection string. It already loves your database. And then you can just scroll down here. It even greets you. Hi, Norbert. I mean, that's nice. You have to appreciate these small things in life. So there's our database. I click on it. Look, there's our table. I click on it. Wow, a fancy SQL viewer. But that's OK and nice. But it has this magic button called X-ray. Now, this is the part where it sometimes works, it sometimes doesn't. But I mean, you need some adrenaline in your life. Anyways, it does a couple of things, but we're actually interested in our queue times. So we tell Metabase that, OK, I'm happy that you're doing this nonsense for the whole table, but I want to look in depth into queue times. So I press that button. And as you can see, it does its magic. It gives you a couple of information right out of box. For example, how many records you have. So as you can see, for all border traffic entries, we have 12 million records roughly, with 11 distinct values. That's because police.hu reports values like half an hour, 4 hours, I don't know, these kind of values. And how that's distributed, you can see that most of these values is really 0, there's no queue at the border. It also gives you a nice summary of the table. It says that 36 million minutes were spent waiting on the border. That's roughly 70 years. Nice, nice. It also lists a couple of other things, like that the most time is spent towards Serbia. Afterwards comes Ukraine, and then Romania, and so forth. And we don't have Slovakia. Don't ask for it. Complain to the government. But actually, there's also a nice feature that I wanted to show you. You can create your own dashboards. But that's not the best feature of it. Let me go full screen. You can also create your own charts here. And the best feature of all. George, where are you? George loves nighttime mode. Just for you. So, as you can see, I created my own dashboard. And what's interesting, I removed the empty values. So I don't care about no queue time. I want to know if there's a queue. Usually, how long does it take? It says 70 minutes on average. I'm not happy about that. This I already covered, that the amount of time you spent. And actually, I also created a couple of charts that show you the entries from November when I imported to this database and how it looks like. So you can have this in real time or regularly sent to you. But what's cool is that you can always zoom in on this and get some details. And before I forget, you can also always download the data you filtered for in various formats directly from Metabase. This is useful when you start doing next step, more in-depth analysis, where you are not necessarily comfortable in doing that in SQL. You can do full SQL here as well. It has an editor. But the main takeaway from this thing is that you see how the queue changes. These are the queue times for Ruska crossing down south. And if it seems like a linear data, it's actually not. Our data here is really, it's not linear, non-continuous, sorry. It's non-continuous, meaning it goes from 30 minutes wait time to 60. There's no in between. There's no wait time of 42 minutes. It's either 30 or 60 or 180. So that's an important property of our data set. It's also ordinal, meaning we know that in this domain, it makes sense that 60 is more than 30. Because you can compare those two numbers. But if I think about crossings, we represent crossings with a crossing ID, 1, 2, 3, 4, 5. Does it make sense to compare 5 and 4 when those are just IDs for a number? You cannot compare a crossing from Brusca to, I don't know, some other crossing. But if you just dump your data this way, your mathematical algorithms will try to do that. So this is this is also part of what I'm going to talk about now, is that there's also not so good parts of data science, where you need to do all these transformations for your data to make sense and all this cleanup. Starting with imputing the missing data. Imputation is a term used for filling those values that are missing with some default. But it sounds much more tough if you call it imputation. Like Metabase, for example, does this for you. If there's missing data in your data set, it does linear interpolation to fill those missing values in. You can also do it by hand using a mean value. It's really straightforward, but job that you have to do. And there are, let me tell you, you will have missing data. I just outlined a couple of reasons why I had this, like power outage at the crossing station, I don't know, somewhere at the southern border or whatever. You have missing data. You bug in your own software, easily leads to missing data. Also, there's the other part. The data you crawl for, or actually you read from anywhere else, it doesn't really matter, is not consistent. How many ways can you write down 4 hours or half an hour? A lot of ways. And I just put here some unit tests that I created for verifying that conversion from 4 hours, 3 óra, to minutes, which we use, is actually working and straightforward. Again, time. Typos. They do typos. I can no longer identify a crossing because of typos. I actually had to, what's it called, Levenstein distance, introduce that to make sure that if it differs in a couple of characters, it most likely belongs to that group, what I want there. Last but not least, you have to prepare flat data structure for all the processing you want to do. Most statistical algorithms expect a flat data structure, arrays, matrices. That's what you use when it comes to computation. It's very easy to dump that with SQL, especially if you have lots of transformations, even regularly. So here's that. And when you have that dump data, then you can start looking into deeper insights. There's a thing called seasonality, usually in data sets. That means that there's a recurring pattern based on a time of day, months, days, whatever. And since I did a lot of traveling, I noticed that usually over the weekends, it's a nightmare. And I wanted to make sure that I'm not biased, that the numbers outline this. So if you just count the number of queue times that occur on each specific day, you will see that there's a pattern which states that usually the biggest queue times happen on Friday, Saturday, Sunday. I highlighted those values in red and yellow to kind of signify that there's the pattern for us. If we zoom out a bit and check it on a monthly basis, you see that there's also a pattern there. Summer months are hell. Just remember the news article that stated 11 hours of queue time. That also underlines that usually happens in summer. So after doing all this work, you are at a point where you have your data ready in a format which you can number crunch, and also have some idea on how your data looks. So remember, We know that it's non-continuous and ordinal. Those are two important factors. And we know that there's complex seasonality in it because time of day, month, all play a role. This will be important in step 3 when we build our models. This is the part where I say that it was really, really difficult to do with JavaScript. I'm not going to lie, I even verified most things I did with Python. There's a simple reason for this, is because when it comes to machine learning domain, JavaScript is really lagging behind. Here, I'm not talking about deep learning, I'm talking about machine learning. So no TensorFlow, no Keras, no, just plain machine learning. There's one library that I use, MLJS, which is okay-ish. Cryptic error messages, no documentation, but you can, if you're persistent enough, you can get something out of it. Anyways, my goal was to have a reasonably accurate algorithm of predicting the expected queue time. So like 3 out of 4 times seems okay-ish. This is an AI. You're an expert now. So it's very simple at the core of it. You have a function, you feed it some data, it spits out a result, bam, you did the AI. That's actually how a prediction algorithm works. I'm using air quotes and whatnot because I really think that AI is an extremely overloaded buzzword. This is just a simple prediction here, which means that for a given value, you want to have a function that gives you the expected result. That's all there is to it. If you do TDD, it's like kind of similar. I write my test first, then I expect my function that I still haven't implemented to give me back the value I want. Bam, you're doing regression. The difficult part is that you actually have to figure out that function. For that, since we have our data in pairs, like we had a bunch of data, that was a queue time. Since we have this labeled data, we can say that we can do supervised learning because we already have some guiding lines on where we have to move around. The other part is just, as I wrote there, is just figuring out a mapping function. I mean, if you use the array map, you're halfway there. The next part is regression, which is a method for helping you figure out that function. So you can use regression if you have some numerical values or continuous values, whatnot. But essentially, those are already research methods that you can rely on. You don't have to figure this out on your own. Just look up some manuals and whatnot. However, before we can get to the F, we don't even know what our input is. So it's called feature extraction. So we have a bunch of data, right, which we recorded for crossings. But what's relevant for our use case? Any ideas? Come on.
Number of day, the month.
Exactly. So date and time. Anything else?
The place where you're crossing.
Just one.
The place where you're crossing.
Yeah, place where I'm crossing.
Holidays also can be
Public holidays, yes.
on both sides.
Exactly.
Maybe better.
There's a lot of things, actually. There's a lot of traffic because of German public holidays. Because that route takes you to Turkey. There's really a ton of things you can consider, but you have to do some dimension reduction, find what's really relevant for you. You can do this with data science, you can do this with trial and error, but you have to pick something. In a lot of cases, one input is actually a proxy of another. So if we take date and time and holiday, from date and time we can easily figure out whether it's a weekend or public holiday. Do we necessarily need it? I'm not going to go into details on what you can do. Start simple. That's usually a good advice in most situations. So how can we represent the date? Well, as we heard, we take the month, we take the day, we take the hour, minute, put it in a vector, bam, that's our date. I also added one additional input parameter, the isWeekend part. It actually doesn't make a big difference. I just left it there for now. But if I remove it, the difference is negligible because it's actually a proxy of the date. And the reason you have to have this representation, because remember, we have to feed this to mathematical regression functions that have no clue about your data. They don't know what it represents. It's just some numbers that they add, divide, multiply, whatnot. So you have to have your data prepared. We did that in the previous step. Now comes the question, okay, which regression method do I use? If I Google supervised learning regression, I get a bunch. Which one do I use? Remember what we found out about our data. That already gives you some hints. The other part is, I'm not going to bullshit you, trial and error. And hitting the manuals and learning and whatnot. Same as for software engineering. There's no silver bullet. After a bunch of, so I actually created a bunch of models. At the end, I ended up with decision tree because of how our data looks right now. I would not say that that's going to be the best result in the long run, but for now, it works well. What you need to know about decision tree regression, and I'll show you in a bit, and you understand why it matches our problem domain. Given a bunch of values, x1, x2 are our features. Think of it as month and day. I plot it on a chart, start putting my data. You see the scatter plot there. I start drawing sections. So just try to split the data up. Let's say if all those things that are smaller than 20 are on the left-hand side, all those things are bigger on the right-hand side. I keep doing this. Actually, the algorithm keeps doing this based on its internal algorithm, so you don't even have to think about that at the start. And then you end up with sections. Now, if I get a new input, I can easily calculate a value for that. So in our case, let's see the queue time. I check which section this new value falls into. And then I see all the data that's in that section. I calculate the mean of it. There's your prediction. It might be more familiar to you this way. A bunch of if and else. That's all there is to it. We just don't write it by hand, but just call a function. That's the whole prediction engine of this thing. Those 3 lines. But interestingly, it works quite well. We have 45,000 samples of data. We split that up, let's say 2080 styles. So we take roughly 35,000 samples to train our model. And the remaining we use to verify that our model works well. We can easily do that because we know that for a given input, we expect a given output. In our case, it's even simpler because we have 11 distinct values. We want to match those 11 distinct values. And as you can see, if I just compare the differences, I didn't even go into these squared root error differences. No need. You immediately see that there's a 3% difference in the predictions. This is all. It's simple here because you build up to this point. As you said, we went through a journey. We don't start with this, we build up to this. And I also skipped some parts where I had terrible nights, but that's not important. What's important is the question I asked in the beginning. Don't forget about our trip. So let's see what hot are things. This is actually a prediction of Ruska motorway traffic for this Christmas. As it says, I should visit my mother in the middle of the night on 26th. Yeah. Awesome, right? Anyways, conclusion, you can do this with JavaScript, but it's not going to be fun all the way. I hope that this will improve, to be honest, but I see it more of a trend towards deep learning rather than machine learning in JavaScript. And I also always encourage people to try new things out, like right tool for the right job, but this was just a case study, not a real-life productive environment. As for next steps, I bought the domain already, come on, that's the coolest name ever. And for next year, actually, I want to do another talk with JavaScript and deep learning based on satellite images of the border crossing, because you see those tiny cars. Counting cars, that should work. And also all this is open source. You'll find the data set and everything and my half-finished branches and whatnot there. If you're interested, feel free to give feedback as well. I also outlined some of the references that I used. I can really recommend all these 3 sources. They are awesome. They are really to the point, get shit done kind of, and then you can later go into the details. That would be from my side. Thank you for your attention.